Okay, we're going to talk about formulations now. If you understand this concept, then to be honest, you don't need to do very much in this presentation. It's only if you get a bit confused as to why we work with formulations in the way we do. So when we have formulations, they can be, it's really about ways of putting things together, putting different products together, different substances together to get a final product. And there's a number of ways in which we can express those. So they could be as a number of parts, so 3 parts of one product to 2 parts of another. We might express it as a percentage, so 20% of drug X and 40% of lactose, and then another percentage of something else. Or it might be that we actually use quantities, as we saw before in the formula for the peppermint water. The important thing here is to know what it is you're looking at. And I think it's where people go wrong is that they get confused between the different parts of a formulation, the way they're expressed. So this is really to hopefully just provide a little bit of an idea around some of the thinking behind the way formulations are and the way that calculations are given to you in calculations exams, etc. There is a link here. The link goes through to Student Central, so you can go to that on formulations, which is really just a written form of information for you. Just it might help you in a slightly different way. Okay, so what have we got? We've got a formula, and what will tend to happen is this will be given just like in a recipe book. You will be given what they call a standard formula or a master formula. So you can see here that we have sodium bicarbonate. We've got 10 grams of that. Sodium chloride, 15 grams. This concentrated peppermint emulsion that we had before is 25 mils. Double strength chloroform water, 500 mils. And potable water, drinking water, to 1000 ml. And you can see that this is made up for 1000 mils, 1 litre. So one of the ways in which calculations happen is you're asked to calculate how much of a particular substance, let's say in this example, let's say sodium chloride, how much sodium chloride do you need if you were going to have 200 mils of the final formula? So that's the type of way in which some of these questions are given to you. Now there's another way we could express that. So you can see here that we've got in one column we've got the amount, but we've actually expressed it a slightly different way in that sodium bicarbonate 10 grams, 10% weight volume. Sodium chloride 15 grams, we've made it 15% weight volume. Syrup is 20 ml, 20% volume. Can you see a problem with the way that that's expressed as percentages? Hopefully you came up with the idea that actually it's very difficult to do an exact percentage if you're using solids and liquids, because you're measuring slightly different things. You're measuring volume as opposed to weight. So actually you have to always be conscious of whether it's possible to express a formula in different ways. If we go on and we now look at the ways in which a formula might be expressed, that would be okay. So we've got sodium chloride here, 1 gram, and the amount of lactose is 4 grams. So you can see that the total amount of solid here would be 5 grams. And that could be expressed as 1 part of sodium chloride and 4 parts of lactose, or 20% of sodium chloride and 80% lactose. Each of those would be fine to express it as long as you use the same column, as it were. So there's no point in saying 1 gram of sodium chloride to 80% of lactose. If we look at the parts just very quickly, you can see here that it says it can be said as either 1 in 5, because there are 5 parts in total. So for sodium chloride, one of the parts in the 5 is sodium chloride. Or you can say it as 1 to 4 parts of lactose. 1 part of sodium chloride to 4 parts of lactose. Both are fine and both are equally as valid, but it's important to know which is which and to be aware of that when it's written in a question. And if we look at a liquid equivalent, very similar idea here. So we've got 20 mils to 80 mils and 20 parts to 80 parts. And it comes out, if it were more than 100 mil, it would be obviously different figures for the percentage. But as it's 100 mil, it's 20% and 80%. So you can see here that formulae are fairly straightforward as long as you remember what it is you are looking at. One of the things I want to highlight here is this idea of the formula being made up to 100 mils rather than saying add 80 mils to 20 mils. You could do both in this situation. The difficulty arises when we start to talk about the mixing solids and liquids. So if we were mixing, let's say we added these two together and had the 1 gram of sodium chloride, 4 grams of lactose, 20 mils glucose solution, 80 mils water, then we would obviously have a different amount at the end. And if we were to say add 80 mils of water to that, then you wouldn't have an overall amount of 100 mils. There would be a slight difference because of the amount of space that sodium chloride and lactose take up in the solution. So therefore we say we make the product up to the final amount, because water is basically just a diluent. So we will very frequently in formulae you'll see 2 100 mils or 2 1000 mils, and that's what you have to make the final product up to. Okay, so if we talked about calculations, what sort of calculations are you likely to get? Very frequently you will be asked, you'll be given a formula, the master formula, the recipe if you like, and you'll be asked to say how much of drug X do you need to use to make, say, 3 or 4 times the master formula. So if the master formula is for 1000 mils, it might be that you have to make 2 liters of it. It might be that you have to make 100 mils of it, and you have to adjust all the ingredients to come up with the final answer. And you can do the same thing by reducing or increasing formulae. And then you may have calculations which really ask you to know and to realize that you are using different ways of expressing amounts. So you might be using parts or percentages. It's not so much the numbers that matter here, it's the logic. You need to think it through and say, well, if I've got a solid and a liquid, then I have to consider it differently than if I have 2 solids or 2 liquids. And this is Michael Johnson. As far as I remember, still the highest earning sportsman in the world. Huge inspiration in basketball.